All right. Hey guys, welcome to this week's lesson. Last week we provided an overview, and I was reaching out, actually 2 weeks ago now, provided an overview of kind of where we're at in the semester. Last week I did reach out to you guys individually. I gave you guys some kind of review one-on-one videos. If you have not gotten one of those, or you haven't gotten a chance to review what I sent you, please reach out, and I'd be more than happy to connect and talk about any kind of gaps that you may have in kind of what your knowledge base is right now with what we're covering. Um, so I did make the midterm more of a project-based midterm, basically the last assignment that we had, which was the physics simulation of the ball dropping to the ground. That was really considered the midterm at this point. And I think that makes sense for this level course where the work is more project based, really trying to gear up this idea of project based work in this course. And I think it's more geared towards, after you guys graduate, where how the real world operates, right? We're not going to be given tests and stuff like that when you're doing actual work, but clients and your employers um, will expect deliveries on certain things, typically project-based work. So a lot of the stuff we've been doing in this class has been project-based, really kind of working along with these videos as I go through and develop a lot of this stuff. Haven't really put out too much in terms of, hey, I didn't do this already, go figure it out. I'd like to get to that point. I'm not sure we will, but I'd like to move on from the actual ball the platform simulation that we started to work on, because we could spend a lot of time on that, and I don't want to spend the rest of the semester just on that. So just to kind of wrap that up, right? Where we left off with the platformer, right? We have these two files. We have the platformer.html and the platformer.js. And again, I am in my environment here at app.stackstarter.io, and you can go ahead and log in. I think you guys all are connected to this successfully, and then you have your build and your run. So if you go to run, it'll actually give you either a directory listing or execute the index.html if you have not yet renamed that to something else. And here I did rename it so I could see my files here. And if you click on platformer.html, you'll see this little simulation running. Now, I think what I'll do too is in this video, actually maybe like right here, if I could figure out how to put it right on my finger right here, or actually I think I'm small in the window, so maybe in the center of the screen, I'll put a link right to the code for this, so you can grab the actual code if you do not have it running successfully. But I think all of you did submit this, so if you did want to actually just play around with this code to see what maybe you can experiment with it a bit. I feel like at this point, at this level, a lot of the learning happens experimenting, right? In anything, not just, P5JS, JavaScript, HTML, web development, anything. Your 3D applications that you may be learning, and really anything is kind of this experiential experience, right? You experience through experimentation, and that kind of unlocks these different amazing things that you can discover really by just tinkering around with a lot of this stuff. So it's a very kind of wide world out there for you to experiment with technologies on the internet. It's kind of exciting. So with that being said, if we look at the code for the platformer.js, really what I would have liked to get to with this project is get to the point where we can actually have some jumping using maybe a little bit of animation and collision detection. But I realize I may be a bit too ambitious with this. So, what we did here is we really introduced the idea of vectors. That was kind of like the underlying lesson for this platformer. It wasn't to create a platform game. It was to introduce you to vectors, which are a critical component in learning a lot of different aspects of game development, specifically how physics work and how a lot of animation works within game engines themselves, right? You could fire up, like here I'm on my home PC. I have a bunch of game engines here. Like I have Unity 3D. I have Unreal Engine, right? Actually, this is Unity. This is Unreal. all of these game engines, these larger game engines, are very well developed, where a lot of these types of ideas like vectors and stuff like that are abstracted away from you, where you're not really necessarily interacting with them on a basic level. But once you go any deeper than the basics, you're most likely going to be touching these ideas and getting involved with, you know, basic linear algebra like vectors and matrices and things like that. So really the point of those previous lessons were to introduce you to these vectors. And if you're struggling with any of these ideas, please do not hesitate to reach out. I would love to connect with you guys and just hopefully clarify some of the things we're doing here, because it's quite powerful stuff. The kind of the second level lesson in this platformer was this idea of actually developing a physics engine, right? We developed a small physics engine here, right? We're using basic Newtonian physics to actually simulate physics, and specifically gravity, right? So we've got these ideas of velocity and acceleration and position and things like that, and they're all related together. And real deep down in there, guys, I'll tell you a little secret here. You just learned a ton of calculus in this too. This is the basics of calculus. If you've never taken a higher level math course before, like Calc 1, Calc 2, or Calc 3, or any college calculus, this is calc. It's differentiation, it's integration, it's all there. I almost feel like it should be taught this way first, and then you talk about all the scary mathematical notation. So, I would have liked to get to the point where we can create jumping and things like that, but it's pretty simple to do that. When we have this apply force method, we could just kind of apply different forces to a character, and one of those forces could be jump, right? Where it's just, instead of applying the force right in the setup function, we can apply the force maybe at a keystroke when somebody hits space, maybe apply an upward force to that character. So we may circle back to this when we integrate some of the physics into a particle system, possibly. But if anybody wants to take this further, we could take it offline, and we can talk about it there. But I would like to move on to different topics now. So we're going to go ahead and close out of this platformer. And where I'd like to take this now is talk about particle systems. Right? Particle systems is something you've seen since the beginning of this series of courses, right? We kind of started this course with an introduction. Really, the 150 course started with an introduction with a particle system on the screen, right? I didn't go into how to develop that at the time, right? Because there's a lot of fundamentals that we needed to build upon to be able to get to this point. But today I'd like to introduce how to actually create these. And this is a page I'm going to link these a couple of pages into the course, into the links section of the course. If we kind of dive into week 8 here for particle engines, I'm going to go ahead and put it into the required materials folder, and I'll put this video into the instructor presentations folder. And it's kind of interesting, right? This is actually a Khan Academy series, and I popped into a couple of these, and I thought it was really interesting. They're using P5.js in this, and but they're using kind of an older way to write JavaScript, which I'm going to use a bit newer way. I'm going to use class notation instead of these functional classes that you see in this lesson. But this is kind of interesting. Particle systems in 1982, a gentleman by the name of William T. Reeves, I guess, invented them here in while researching effects for the movie Star Trek II. Specifically, this scene right here. 1982 is when we saw the first particle system used in films. And you can see here it was used to kind of create this simulation of an explosion that took over the entire planet, right? I guess they were trying to terraform a planet here, and they just nuked it, right? And all this is a particle system. This was implemented in 1982. That's pretty amazing. Now, these techniques have been used since then in special effects across the world, right? A lot of the movies we see that see destruction and explosions, and video games that you could fire guns with, and there's explosions happening, maybe smoke and fire. All of that is done with particle systems, right? And if you guys are learning like Maya and 3D Studio Max or Blender, there's a little button that allows you to create particle systems, right? And you can say how many particles you want. There's a whole bunch of different parameters that you can pass in and change the way that a particle system should render. What we're going to look at today is how to create that from scratch, right? How to create that using code. How do we actually communicate or develop the ideas of a particle system, right? And I think you're going to find that it's a bit simpler than we may think. But there are a couple of core fundamental programming aspects that we need to understand in order for us to really work with particle systems. So what I'd like to do is I'd like you guys to follow along with me here. So I'm going to go ahead. I'm going to get back into our editor here. And in the root directory here, I'm going to create a new file. I'm going to call it particles.html. Okay. And if you're not naming your files this way, I would recommend you do that where it's just one word, all lowercase, keep it very, very simple. And what I'm going to do is I'm going to go ahead and just copy over the HTML, right? I'm hitting Control A, and then Control C, which is going to copy everything. And then I'm going to go into the particles.html and just do a Control V to actually paste that in there, right? Now the only thing I need to change here is I'm going to change this platformer.js to particles.js. Okay, just gonna make sure I'm still recording here. Good. I did one of these the other day. I was recording for about an hour and then realized I wasn't recording. And boy, was I not motivated to get back into it again. I'm like, oh no. Okay, so now we have our particles.html and we have our script linked to this particles.js. Now, we don't actually have a particles.js yet, right? So we got to go ahead and create that bad boy. So let's go ahead and create another file, and let's call it particles.js. Okay. Now, before we do anything else, if we go back here and go to our directory listing and just refresh this, and again, I see this directory listing because there is no index.html in the root directory. I renamed the original demo that I had here to 3js_demo. Okay, so if you don't see this listing when you hit refresh, it's because you still have an index.html. All right, so now I can go here and click particles and nothing's going to happen, right? Because we have nothing going on. There's nothing there. So that's okay. So let's go ahead and let's start a new P5.js sketch. So this is probably me sound like a broken record, but what are the two core functions we need? We need function setup, and we need function draw, right? Okay, now within our setup function, we're going to go ahead and create a canvas, and we'll make that the window width and the window height. Watch my case here, right? This is capital W, capital H, right? And make sure you're spelling canvas correctly like that. And we'll set the background to be white. So I'm going to say background white. Perfect. Now, this should actually, you know what? Let's make the background black so we can actually see that it's working, right? So I'm going to make this background black. Whoops. We'll save that. Now, if we go back here, we should see a black background, right? Let me do this. I'm going to split my screen up so that the code is on one side and the application is on the other, so you guys can kind of see it going along. I'm going to collapse this. Okay, so now you can see this is working, right? If I go ahead and make this white, it's going to change to white. If I make this to red, it's going to change to red. Okay, awesome. So we've got we've got a sketch running. Now, the first core concept that we really need to understand in order to develop a particle system is this idea of a class and an object. Now, this is something we did touch on in the 150 course towards the end, right? And we did use it in the platformer project, right, where we created a character and we created the ground. So this idea of defining a blueprint and then using that blueprint to build things in our program, right? So I always go back to the kind of the home analogy here, where it's like, hey, I need to build a house, or I need to build a series of houses. I first need an architect to create a blueprint. From that blueprint, I can create as many houses as I want, as long as I have unlimited resources and money, you know. But the point is that you can actually go and use a blueprint to build many of the same house. It's the same idea with this object-oriented programming, right? Where we create a class. The class is a blueprint, and then the actual object is the house, the actual constructed house. We call that an instantiated house. We instantiate objects from classes. All right. So why don't we kind of talk about a single particle first? What is a single particle? Now, I could do this and say, hey, let's go ahead and draw an ellipse at 2020 at 20, 2020 in a radius of 20. And there we go. We have a nice little white circle. We could call that a particle. It's a particle. Awesome. We're done, right? No, that's not a particle, because we don't have any control over it, right? We don't have any way to change the position of it. We don't have any way to kind of maybe attach physics to it, or maybe create multiple of them, right? It's a very limited view on what a particle can be, right? And when I say particle, I'm speaking in pretty general terms, right? Like when, you know, particle systems are used to create these kind of, actually, how did Khan Academy put it? I thought they put it pretty well here. Yeah, here we go. A particle system is a collection of many, many minute particles that together represent a fuzzy object. So I think that's an interesting way to put it, because, you know, you can use this to make it look like smoke or fire, right? If you think about smoke, if you zoom into smoke, at the end of the day, they're little particles, right? And if you zoom out, it makes it look like it's this kind of just like, you know, cloud in a sense, right? But particle systems can be used for everything. You can almost think about the universe as itself as a huge particle system, right? We're made up of particles. The universe is made up of particles. Everything is particles, right? We're solving the question of nature here with our particle system. But you can think of a particle as just a fundamental dot, right? A single dot, right? Just like we see here, this single kind of circle, right? But we want more control of it, right? Why don't we take this idea of a dot and put it into its own class, right? We define it its own blueprint, right? So we could go ahead and below the draw function, we can say class particle, right? Open and close that class. Now we have a class. So now we have this blueprint, right? We have a blueprint. Within this blueprint, let's create a constructor, right? And that constructor is going to set some initial values for us, right? So we could say maybe, let's define the size, and we'll make the size maybe 10. And let's maybe, let's create maybe a position vector, right? So we can go ahead and say this dot pass equal new, what do we call it in the platformer, right? We're going to do this exactly how we did the platformer here. So we go back to our character. We're just calling this function called create vector. So we don't actually instantiate a vector manually with P5.js. We call this create vector. So I'm going to go ahead and create the vector, right? So we're going to say create vector, and for simplicity's sake right now, we're going to change this, but I'm not going to pass in an X and Y value. I'm going to hard code it at 10 and 10. Okay? So we're going to hard code the position. Now, let's create a draw method. Now, this draw method is going to be used to actually draw the particle. Now, when we think of a particle, right now, the mental model that I'm kind of drawing for you guys is this dot, right? But technically, it could be anything, right? And we're in control of what it is in this draw method. So I could say, let's draw this as an ellipse at this dot pos dot x and this dot pos dot y, right? So we're accessing the components of the position vector to be able to grab the position values and pass them into the parameters of the ellipse, right? And then we'll say this dot size. So we just basically made each one of the parameters of this function one of the actual members of this class, right? They are variables within the class itself that we're using to draw this ellipse, which is basically a circle, right? Okay, awesome. So we're here, we have this particle, we have a constructor, we have a draw method. Now, let's actually use this bad boy, right? So instead of going here and saying ellipse in the setup function, I'm going to go ahead and define a new particle. So I'm going to say my particle. I'm just going to call it my particle, right? Well, whoops. Oh, what am I doing? I'm going to say let my particle equal. Now, how do we actually construct an object out of a blueprint, out of a class, right? We use that new operator, right? New space particle. Okay, cool. So now we have a built particle, a single particle, and we're storing it within this myParticle variable. But why isn't it drawing anything? We have a particle, right? How can we verify that we actually have a particle? Well, before we call the actual draw method, if I go ahead and right-click this window and I go to inspect, all right, I'm going to get out of this mobile view here because I was doing some mobile development before. I'm going to go up here and I go to console, right? If I go right below this line and I say console.log my particle, man, I am sloppy on the keyboard today. All right. You also have to spell it right? Because I'm definitely, there we go. Now you'll see down here, I'm actually writing out to the console the contents of this variable. And you can see the contents of this variable is a particle. It's a particle, right? It says particle, it has a size of 10, and it has a position, which is a p5 dot vector. Awesome, so we know we have a particle. So let's try, I'm gonna go ahead and delete this console.log, delete my particle, this piece right there. And I'm just gonna say dot draw. I'm going to call the draw method on this particle. And look what happened. We have a little tiny circle. But this circle is now a particle. It's encapsulated in this blueprint, this class, that we can now instantiate or create many copies of it. That right there is super powerful, right? That's like the fundamental layer of this lesson, is the fact that we have this class that we can now create many copies of itself by using this new operator. Now, what would be exactly the same if we created more copies of itself, right? So if we said, if we copy these two lines of code and we go right below it and we say new particle 2 and new particle 2.draw, nothing is going to change. But we just created two versions of it. Now, what if we did this? What if we said the position down here within the actual blueprint itself, or within the class, we say random 100 and random 100. Now, every time we refresh this page, we're going to see two particles in random points of the screen. right? Okay, awesome, awesome. So we're getting there, right? And we could go ahead and copy this again and create a third one. We can get crazy with it, right? Okay. But now, what if we wanted to actually make this so that we can pass in the position of the particle, at least the initial position of the particle, into the constructor? What would we do there? Anybody have any ideas how we would do that? Would we maybe use these parameters here when we say new particle? So we could say new particle, and we could say random 100 and then random 100, right? And could do the same thing when we create it down here. I'm just going to go ahead and copy and paste that. And now, is it using these values we passed in yet? It's not, right? We have to extend this constructor and say the constructor takes in x and y as a parameter. And now we could say here x and y. And now it'll do the same exact thing, but now we have flexibility in our particle to pass in the initial point, right? Say, for example, we wanted this first one not to move any random place. We want it to stay at 10 and 10. So if we just pass in 10 and 10, you'll notice here, now only one of those bad boys is going to randomly move around the actual canvas, and one is going to stay fixed. Right? Okay, cool. So now we're at the point now where we have a blueprint for a particle, and we can instantiate or create many copies of it. And we can pass in its initial position into the constructor. Now this, when you think of a particle system, you don't really think of a single particle, right? You're going to think of multiple particles, right? Many particles. In many cases, in big VFX applications, it could be millions of particles, right? To really create that realistic looking smoke or fire, there's a lot of particles, right? We need specialized hardware to crunch all the numbers for millions of particles on the screen at any given time. But what we're learning here is really the fundamentals, right? We're learning the layer one of what it makes all of that possible, right? I think once you start to really grasp these concepts, it almost takes the magic out of the magic trick, right? Where you're looking at these effects and you're like, oh, that's a particle system. I can see how that's done, right? And these higher level tools, like I said, they allow you to basically drag and drop a lot of these things around the screen, and you don't really have to know the insides in terms of how they function. You're basically doing what we did here. You're configuring the parameters, right? In the user interface, you may have a little slider bar that says number of particles, or an input, a text input. That eventually gets passed to something like this, which is a function, right? The constructor, right? Or some method inside of the actual class. So, okay, so how do we actually now create a particle system? Not just a single particle, but a full-blown particle system, right? And sometimes these are called emitters, particle emitters. They're something that emit new particles, right? We can do that by actually creating another class. And that class is going to be responsible for being the actual particle system, right? So why don't we do this? Let's go back to the bottom of the screen here, outside of anything, and let's go ahead and say class particle. I'm going to call it an emitter, particle emitter, right? This is going to emit particles. Okay. Now, well, before I get into that, let's create a constructor. It's going to be the same exact pattern, right? So we're going to have a constructor. I won't pass any parameters into it yet. And that's it, right? So now, really what a particle emitter is it's this blueprint around this idea of a list of particles. Now, how can we manage a list in our program? This is one of those fundamental data structures that we use all over the place when we're doing software development. and that's called an array, right? We're basically going to keep track of all the particles in an array. And I wanted to kind of draw that out real quick. I have a little sketch here in Figma, just to freestyle a little sketch here. So when we talk about a single variable, right, we could think of it as a bucket, right, where we can put information inside. So here I've got a single variable. I'm going to put a value of 10 inside of it, right? So here we go. We have this value of 10 inside of this bucket, and we can give it a name, right? We could go ahead and say our variable name is say it's the size, right? So now we have this variable, and inside of it is the size. Perfect, right? Now, if we had multiple sizes that we wanted to keep track of, right, we could have multiple variables. So if I take this and I paste it, I could say size 2, and now size 2 has maybe a value of 20 in it, right? So we have these two variables. Now, we can keep going with this, right? We can have another variable here called size 3, right? And say we have the value of 30 inside of it. Now this will work, right? And the way that we would visualize this in code is we would go back here and we could say, you know, let size 1 equal 10, and then we'll just do this 2 more times, and we could say let size 2 and let size 3 and 20 and 30, right? So this is the fundamental idea of a variable, right? We have these buckets that we can store information inside of, and then we can use those buckets in other areas of our system, right? So instead of saying 10 and 10, we could say size 2 and size 2, and you'll notice this little guy's going to move over a little bit, right? Or we could say size 3 and size 3, and now it'll move over even more, right? Because the value is now 30 within here. But say, for example, we needed to keep track of 1,000,000 sizes, right? How would we do that? Would we go here and say, all right, I'm going to have 1,000,000 lines here. I'm just going to keep going, and just, you know, I'll put 1,000,000 lines in here, and then we'll sit here and change each one of these to 3, 4, 5, 6. Uh-oh, are people shutting off the video now? No. Yeah, we're going to be here for a while, right? We could do this all day, and it's going to be a horrible experience. It's going to be horribly, you're not going to be able to maintain your code. It's just not the way to do things, right? We have better tools than that, right? So to solve this problem, what we can do is we can use arrays, which allow us to keep track of lists of variables or lists of buckets, right? So if we go back to this visualization, what we could do here is, instead of keeping track of all 3 like this, we could define a variable that kind of wraps this entire thing, right? So we could take a variable here and wrap the whole thing, right? And let's go ahead and pull this down here. And give it a, there we go. We can add a variable that wraps the whole thing, right? And then we can name that. So we could say, all right, this is sizes, right? So this whole thing will have a name called sizes. And now, instead of accessing the information in the individual indexes by name, which we can do, it's a little bit different data structure. You can learn about that in the future. But for now, it's indexed by just a simple number starting at 0. So this would be 0, right? This would be 1, right? And this would be 2. So sizes sub 1 would be equal to 10. Sizes sub 0 would be equal to 10. Sizes sub 1 would be equal to 20. Sizes sub 2 would be equal to 30. Now, all we have to do is have a single variable, which would be an array, that keeps track of all this information. So if we go back here, we could say, instead of size 1, size 2, and size 3, sizes equal. Why does that look like it's not spelt right? Now, you ever get those words where you're just like, that doesn't seem right? Is that how you spell sizes? Yeah, I guess so. You get those words that just don't look right, but they are. So you could say sizes equal, open bracket, 10, 20, 30. And then you have a close bracket there. So now this is an array. An array, right? And now we can access information inside of it by doing this, right? If I copy this and say I wanted to make it equal to 10. So it'd be sizes sub 0, right? Sizes sub 0, right? And now that guy's going to be chilling out around 10 and 10. If I want to go ahead and say sub 1, now it's going to move over a little bit. Now it's at 20 and 20. Or if we want to make it go to 30, sub 3, sub 3. And now it's at 30 and 30. Actually, that looks like it's, I'm sorry, not sub 3, sub 2. Sub 2. There we go. Now it's moving down, right? So this is 0, 1, and 2, right? Remember, it starts at sub 0. 0, 1, and 2. And this color is horrible. There we go. There we go. All right. So that is kind of like a really brief overview of what arrays are, right? They allow us to keep track of lists of information. You can think of it like a list. All right. Now, how are we going to use that in the context of a particle system or a particle emitter? Well, instead of having numbers here, we're going to have particles. So it'd be like particle, or I'll call it P1, P2, P3, right? So each one of these index, and then instead of sizes, we're going to call this particles, right? This is going to be a particles array. Now, if we wanted to get a little crazy, this is actually, this array is sitting inside of our particle emitter. So if we wanted to actually zoom out a little bit more, get a little high level with it, you could say that this is inside of a larger rectangle here that is our particle emitter, right? So this is now our particle emitter. Right? And inside of our particle emitter, we can have a bunch of things like other functions and other arrays and things like that, right? So we can have basically put a dot, dot, dot. We can have other things there, right? We can have other things inside of it. So let's see what this looks like in code. So if we go back here to our particles.js and go down to our particle emitter, we should have this class, particle emitter, and a constructor. Now in the constructor, let's go ahead and create that list of particles. So I'm going to say this dot particles, all lowercase, equals open close bracket. That's basically saying, hey, I'm creating a new list called particles, but there's nothing inside of it yet, right? We don't have anything inside of that list. Why don't we go ahead and actually populate that list, right? So we could say, and I'm going to do this in a very crude way first, and then we're maybe going to use a little bit of a looping structure to be able to automatically create these particles. So I'm going to say this dot particles sub 0. I'm going to explicitly call out sub 0 equals new particle, and we'll give it a fixed position of 20 and 20. Okay. Now, is this doing anything yet? Is this executing at all yet? Have we instantiated the particle emitter? Have we created it yet? We haven't, right? We have to do that first, right? So let's go back up to our setup function. Right now we're doing all of our code in the setup function. We haven't actually used the draw function yet. You could technically just remove it. You don't actually need it for what we're doing right now. But we could just keep it chilling there, just kind of blank, doing nothing for us. I'm going to go ahead and I'm going to delete all of the my particle code that we have here. I'm going to remove that. We don't need that anymore. I'm also going to delete this sizes array. We don't need that anymore either. Right? So now we just have our basic setup function again. We're back to the basics. Now let's go ahead and we'll say let particle emitter, or we can call this anything, right? We could call this PE if we wanted to, right? Just so we don't get confused with the name of the actual class, which remember, capitalize, right? In the first, this is camel case, so you want to make sure it's capitalized for all the actual words in the name. But when we actually define it, when it's a variable, we don't do that, right? We keep it lowercase here. We'll say let PE equal new particle emitter. And you'll see that the editor will actually try to auto-complete this for you. But it doesn't look like it's gonna. There we go. Open and close. All right. Now we have a new particle emitter, but nothing's drawing to the screen yet. What the heck's going on here? So nothing's there. Why is there nothing there yet? What do we have to do here? What are we missing? We need a draw method, right? We need a draw method on the particle emitter. We need something that's actually going to call the draw method on the particle itself, right? So let's go ahead and say draw, right? And it doesn't have to be named draw, right? I'm naming it draw because it makes sense to name it draw because that's what we're doing. But I don't want you to get confused with the draw method here. This is the P5JS draw function that gets called automatically by P5JS. Here, we're creating our own particle emitter with its own method, and we're just calling it draw. So here, let's go ahead now and say this dot particles sub-zero dot draw. Okay, now we still don't see anything. What the heck is going on here? So we don't see anything, but we are now drawing. But are we calling that draw method here? We're not, right? So now we need to go here and say pe.draw. And I hope some of you are seeing the pattern here. Like a lot of the stuff that we're doing, I'm doing the same thing over and over again, just with different, really different objects, different classes. It's the same pattern, right? We're using the new operator to construct this object from a class, and then we're calling methods on that newly constructed object, all right? And you can see now that we called draw, look at that. We actually have a particle on the screen. Awesome. What I'm going to do here is I'm going to copy this, and I'm going to put this onto gist, and I'm going to link this into the super basic particle system, right? And this is called particles.js, right? I'm going to link this into the class at this point, so that I'm going to now go into a little bit of looping and things like that, but I don't want to remove things that I think, I don't want you guys to miss stuff that may be deleted very soon. So I'm going to go ahead and create this and link it in the course so that you guys can get access to this. Okay. Okay, cool. And I can actually have revisions on this, so I may actually just revise this a little bit and then put a new revision up. And I think I can link directly to revisions, which would be nice. Okay, cool. So now we have this super basic particle system that literally only knows how to draw one particle, but it is using an array to store the particle, and it's calling the draw method on that one particle. I want to take this to the last step here, and then we'll stop this lecture. I want to now create a ton of particles. I don't want to just create one particle. I want to create a ton of particles, right? So in order to do that, we need to use loops. And I'm going to do that within the constructor of the particle. So I'm going to say here, I'm going to say for, I'll use a for loop here. For let I equals 0, we'll just call the looping variable I. I'll say I is less than or equal to, how many particles do you want to create? Let's go ahead and create 100 particles. Go ahead and say I++. What's going on here? Something happened that something crashed on me. I think the auto load just screwed me up here because it tried to auto load the page before I finished doing my loop, and it's probably stuck in an infinite loop. That's gonna probably crash my browser. So let's see. Okay, I'm gonna refresh this. Exit this page. So what just happened there was, because I had this auto saving, it actually got thrown into an infinite loop, which made my browser just kind of bug out and crash on me. So if that happens to you, that's awesome, because I feel like as you're learning programming, putting your programs into infinite loops is a rite of passage, and you're probably going to do it a bunch of times. So yeah, in this case, right, we kind of reloaded before we said exactly when we should terminate the loop, right? So we're terminating this loop when the I variable gets to 100, right? So we've got I is starting at 0, and we're looping all the way up to 100, and we're incrementing by 1, right? Now, let's go ahead and run this again. And go ahead, go to particles.html. And all right, cool. So now, is this working? I don't think it is, right? We need to actually, we're looping 101 times, right? You see why we're looping 101 times, because we're starting at 0 and we're going to 100. But on each loop pass, we're saying that this particle sub 0 is equal to a new particle. So we are creating a new particle 101 times, but we're storing it in the same index of this array each time. So in order to change that, we just have to change the 0 to the looping variable, which is I. Boom. Now, there is at the end of this execution, this .particles is going to be a list of 100 particles. So I'm going to go down here and say console.log this.particles. Right? Now, if I go ahead and inspect this and open up my console, look at this. We have an array of 101 particles inside of it, right? So if we expand this, you can see that we have a ton of particles now. Look at that. Nice. So we have a ton of particles. Now, how do we actually draw these particles to the screen? Anybody have any ideas on how we're going to actually draw the particles to the screen? I'm going to go ahead and remove this console log. Well, we know we're drawing one of them, right? We've got this draw method, and we're calling the draw method on the particle by just saying particle sub 0.draw. But how would we do it for all of them? If you guessed it, you are awesome. You're going to just basically copy this loop, and you're going to bring it right down here into the draw method. And now in draw, we're going to loop through 101 times. And instead of saying new particle, we're going to say this dot particles sub I dot draw. Awesome. But we still can't really see this, right? Now we have this single little circle here, right? Why don't we go ahead and instead of saying 2020 here, let's pass in some random value. I'm going to say random, random, and we're going to give it the window width. And we'll do the same thing here. I'm going to say random window height. I'm just going to copy this and paste that and say window height. And now look at that. So now we have this random circles being drawn to the screen. Now, this was actually a sketch we did earlier on in this class, right? In this series of classes where we were just drawing random circles to the screen. But now we're doing it in a much more powerful way, where we're doing it using this particle emitter that has the ability to now create these particles and manage a list of particles within itself, right? So now we could do things, and possibly we'll do this in another lesson, where we can apply those same physics we did in our platformer demo to each one of these particles, and then emit them at the same exact point in time, right? And then apply the physics in each frame, so it could look like this, almost like a fountain being thrown out into space. But I think I'd like to stop here, and you know what I'm going to do? I'm going to take this code here. Now that we're using the loops, go here, and I think I can just go ahead and edit this. Paste this in here. All right, and I think this will automatically create a new revision. Now, if I update this, yeah, now I have 2 revisions. And you can see revision 1, which is right here, and then revision 2, which is right here. And I think you can go here and just view the file. So this is revision 2. And then you can go here and view the file. And this is revision 1. So this is good. So this will give you guys the opportunity to actually see this code. You can bring it into your own environments if you're struggling with some like syntax issues where it's not running. If you do want to see it just without the line numbers, because if you copy and paste this, I think it's going to pull some of that in. You could click this raw button, and that'll just give you the code right there. So I'll go ahead and actually link this into the course. All right, guys, so try to get to this point, and that'll really be the assignment for this week, is to get to this point and submit this to the class. And let's see how far you guys get with this. If this does turn out to be a success, I will build upon this and we'll show off how to actually make it look like an emitter. So it's actually emitting particles, and we'll combine some of the knowledge that we've built in the platformer physics demo with this actual particle system. All right, guys? Excellent. Any questions, let me know. You know where to find me. Thanks.